Alright, ladies and gentlemen, it's fourth period and fifth period. This message goes out to you. I've been really sick. I can't get to school, but I will hold you accountable for this information. If there are any problems in the classroom and the kids cannot hear this slideshow, okay, you will be held accountable for this information. The sub will take names, and it will be reflected if there is a problem on your final report card. Also, I will double your amount of winter break homework. So please make sure you are taking notes and you are doing the practice problems so that everybody will learn the material that you are to be responsible for a quiz on Thursday. Alright, so substitute. Please take names if the students are not doing what they are supposed to do. So this is for fourth and fifth period. Please pause the space bar if you see a student's hand go up. So students, if you need more time to write notes, please raise your hand. They'll stop it. If you have a question, please raise your hands and see if some of the other kids in the class can answer the question. So if you don't understand something, raise your hand. If you want to and ask the question, if you want to answer the question, please also raise your hand, and the substitute will call on you. Alright, so today we're looking at solving equations with variables on both sides. We can solve this problem in a multitude of ways. There is no wrong way. Basically, what we have to do is to get the variable onto one side. So I want to take a minute and just show you something. To zero out a variable, let's say I have 3x, okay? If I want to get rid of the whole thing, there's two things I can do here. I know it shows multiplication. Now, I could divide by 3 and divide the whole other side by 3. So I had something like this. Divide by 3. And look, I'm left with the x. It doesn't get rid of it. Alright? So let's look at something else. Let me switch colors here. So if I had something like 3x plus 7 equals 5x minus 19, I could take, instead of splitting that term in half, how could I make it become 0? If I have 3x's, what happens if I just take 3x's away? If I do that, then look what happens. Positive 3x, negative 3x cancel out. I'm left with 7, and the x term has disappeared. Equals 2x minus 19. So, to get rid of something, I'm going to subtract it to move it onto the other side. Alright, I'm going to erase this now. Go on to the slideshow. Alright, so I can do this in a couple different ways. I can do it just the way I just showed you. Isolate the variable onto one side of the equation. So if I want to get rid of that 3x, I'm going to subtract it. And when I subtract that from both sides, I'm now left with 7 equals 2x minus 19. Now, I want to get rid of this negative 19 and move. So I'm putting all the x's on one side, all of the constant terms on the other side. So 19 has no variable, it's a constant term. I'm going to move it onto the other side. So to make it become 0, I would have to add 19. And now I have a one-step equation. that I can solve. Now, I want to get the x by itself. I don't want to make the x term disappear. I want to get it by itself. So I only want to get rid of the 2. So now I'm going to divide both sides by 2. X is all alone, and x is equal to 13. All right, let's try that again. Only this time, let's say, instead of moving your 3x's over to this side, you move your 5x's over to this side. So what would I do to zero out that 5x? That's right, I'm going to subtract 5x from both sides. And now I'm left with negative 5x, positive 3x makes negative 2x plus 7 equals negative 19. Now I've got to get rid of my 7 over here because I've decided to move my x's on this side of the equal sign. So I got to move my constants over to this side. I'm going to subtract 7 from both sides. And now I'm left with negative 2x equals negative 26. Divide both sides by negative 2. And remember, a negative divided by a negative makes a positive. And what do you know? I get the same equation. So the bottom line is, it doesn't matter what you move first. Get all your x terms to one side of the equation and all your constants to the other side of your equation, and then you solve for x. Okay, take a minute, pause it, make sure everybody has the notes. All right, so with this situation, just a reminder, we got to isolate our variable onto one side. Get all the variable terms on one side. All right, so let's practice one. I generally move my lower x term first. You will always see me do that. It doesn't mean that I'm right if you move the other term. It just makes it so my x is not left with a negative. So my smaller x term would be the 3x, so the opposite of 3x would be negative 3x. And now I'm left with 4x plus 5 equals negative 27. Now I move my constant term, subtract 5, inverse operation. And I get 4x equals negative, I owe 27, I owe $5, I owe 32. Now I divide both sides by 4, and x is equal to negative 8. All right, now stop the recording, and you try the next one. All right, so now I'm going to subtract x on both sides. I'm left with negative 1 equals 5x plus 29. Subtract 29, move the constant to both the other side. I'm left with negative 30 equals 5x. Divide both sides by 5, and x is equal to negative 6. All right, check your work. All right, so now Jessie began solving the equation below. Find her mistakes and demonstrate a more efficient technique. So take a minute, pause the video, and see if you can find the mistake. All right, now check your work. Now hopefully you redid this problem just as Jessie did. You started it and started trying to solve it. All right, so as I go through the steps, I have to distribute, get rid of the distributing. Now I'm left with something I can deal with. Multi-step equation with variables on both sides. So now they're choosing to do the constant onto one side. So that's okay. They're not moving the x term, that's okay. They're moving the constants first. And again, that's okay for you to do too. I always generally start with a lower x term. But plus 6 plus 6. I'm left with 3x equals 5x plus 24. So now I'm subtracting 3x. What is wrong with that? What's left on this side of the equation? My equal sign should come down. What happened to the equal sign? It moved over in between these two terms. What's really left on this side of the equal sign is 0 equals 2x plus 24. Okay, so let me see you do that one the right way. Okay, now check your work. Oops. So let's do this. Distribute first. Move my x's to one side. So I get negative 6 equals 2x plus 18. Subtract the 18. X equals negative 12. Notice my equal signs have stayed lined up the whole way through. I want you to work on that. Make sure your equal signs are staying lined up. All right. Now, translating 10 less than, that means minus 10. 3 times a number. So we're going to define our unknown. X is equal to the number. So remember, when I say 10 less than, my terms are going to have to crisscross around the less than. So let me switch over to the pen. Okay. So when I have 10 less than 3 times a number, the numbers that are going to crisscross, that should be a 3. Okay, the numbers that will crisscross are the 10 and the 3x. Is the same as twice the difference. I'm going to send this over to the and of the number minus 7. Difference means subtraction. So let's look at it. 3x, I have to crisscross those, minus 10 equals twice the difference of x minus 7. And remember to define your variable. Okay. All right, so now what would we do first? That's right, we're going to distribute. Now, take a minute, isolate your variables to one side, and stop the recording and finish up the problem. Okay, now check your work. I'm subtracting 2x. I'm to both sides. I'm adding 10 to both sides, and I get x equals negative 4. All right, now you take the time to do this. Take a minute and translate. Pause the recording. Now check your work. My unknown, we're going to call it y. So 5 more than twice a number is 2y plus 5. Is my equal sign. 11 less than the product of 10 and the number. So 10y minus 11. Remember, your terms have to I don't know, I lost my train of thought. I'm so sick right now. Oh yeah, terms have to crisscross around the subtraction sign. All right, get your variables isolated to one side, so I'm going to subtract 2y. I'm left with 5 equals 8y minus 11. Add 11 to both sides, get your constants on one side. 16 equals 8y. Divide both sides by 8, and y is equal to 2. All right, moving on. So when they're looking for the area of the square below, we're going to have to use an area formula. Now you could use the rectangle or the square formula. I don't know why they're saying it's equal. This is confusing to me. I think we would multiply these together. Okay, this is not a good problem because with area formula, this times this gives you the area of the square. Oh, I see what they're doing. They're just, remember, since it's a square, since this is a square, means this side is equal to this side. So they are finding what x is. They're solving for x. And so let's go back. If this is a square, remember, this side is equivalent to this side. So we can set them equal to each other. Now let's distribute and solve for x. Okay, get my x's on one side, subtract 2x. Move my constants to the other side, subtract 6. And x equals 3. If I know that x equals 3, I can find the area by substituting in 3 times 3 plus 2. 3 plus 2 is 5 times 3 is 15. Okay? And 6 times 3. So 15 times 15 is 256. Now we're using it. Okay, sorry about that. We would do something like this in algebra, multiplying those two together. So my area is 225 square units. Okay, so now we're just adding some distributing. Remember, distribute first, then isolate your variables to one side. So if I were to do this, 5 times 4 is 20, and 5 times negative 4 is negative 5x. On the other side, 3 times x is 3x minus 12. Okay, now simplify and solve for x. Stop the recording, and now check your work. All right, that answer should have been 4, x equals 4. Now check the work for number 4. And x equals 3. Oops. You just check your work there for a minute. All right. Perimeter of a rectangle. Remember that if there's a formula for it, we should be using it. So perimeter is equal to 2 lengths plus 2 w's. So if I have two lengths, I'm going to substitute in 2 times, here's the length, 2x plus 6, and 2 times x. It's the same thing as just writing all the amounts of the sides and adding them up. And then we distribute. Now here, I'm going to do 3 times this if it's an equilateral triangle. So pause it, and now solve for x. Now distribute. Okay, now let's go back up to the directions. Find the value of x if the perimeter of the rectangle is equal to the perimeter of the equilateral. Sorry about that. Boy, this is bad tape. So set them equal to each other. So we know that the perimeters are equal, so we can just set them equal, distribute, and solve for x. And x is equal to 8. I don't know what I was telling you to solve for x. All I can say is I'm pretty sick, have some fever, and I'm not at my best. So please disregard any flaws in this. And that's the lesson for today. You're going to do the odds on 7-5. So please make sure that you have the work complete by tomorrow. Hoping to go to the doctor today and get some medicine. So I'll be back.